Hello everyone, I am Mrs. Kishori Abhishek Kumtekar, working as Assistant Professor in Fulton Education Society's College of Engineering in Electronics and Telecommunication Engineering Department. Today we are going to see the practical of the study the input-output quantities of a transformer under the course Basic Electrical and Electronics Engineering of a first year syllabus of a Dibatu University. First, we see what is the transformer. The transformer is a static electrical device that changes alternating current voltage from one level to another level without changing a frequency. Basically, the transformer works on a mutual induction that a changing current in a primary coil produces a magnetic flux which induces voltage in the secondary coil. The different input quantities of a transformer, that a primary side, which is primary voltage, primary current, then primary turns and the input power, and the basic output quantities, that is secondary side, which is secondary voltage, secondary current, and number of secondary turns and output power delivered to the load. In this practical, we have to calculate the values of voltage ratios, current ratios and transformation ratios for the given transformer. So for the voltage ratio, which is the V1 upon V2, which is primary voltage to the secondary voltage, then current ratio, which is the I1 to the I2, which is primary current to the secondary current. Let's we see the practical connections. We will perform the practical of input output quantities of a transformer. So for this practical we required the single phase auto transformer for the giving supply and the moving iron type voltmeter ammeters for the measurement of primary voltage, primary current, secondary voltage and secondary current. Here we will use the single phase transformer for measuring the input and output quantities and the current and voltage ratios, and for the load we are using the resistive load bank. This is the connection diagram for the practical of a measurement of voltage and current ratio of a transformer. Now we will see the connections for the practical from the circuit diagram. The positive of auto transformer is connected to the positive of a voltmeter, and which is also connected to the positive of a ammeter. So positive of a voltmeter is connected to the positive of a voltmeter and is also connected to the positive of a ammeter. Then the negative of a ammeter is connected to the 230 point of a primary winding of a transformer. Then the negative of a ammeter, which is connected to the 230 point of a transformer, and then the 0 point of a transformer, which is connected to the negative of a voltmeter, and the negative of a voltmeter, which is connected to the negative of a auto transformer. These are the connections regarding the primary winding. Then we will see the connections of a secondary winding. The positive of a secondary is connected to the ammeter's positive point. The range we will select the 5 ampere. The negative of a ammeter, which is connected to the positive point of a voltmeter. From the positive point of a voltmeter we connect the positive point of a load. The negative point of a load is again connected to the negative point of a voltmeter, and from the negative point of a voltmeter we again connected the 0 point of a secondary point of a transformer. Now we will see the observations from this practical. Now we will take the readings. First at the 50 volts. So the primary voltage, which is the 50 volts, and the secondary voltage which is the 25 volt. The primary current for this is the 0.4 ampere and the secondary current, which is the 1.35 ampere. Now the second reading is at a 100 volt. So set the transformer at a 100 volt. So the primary volt of a transformer, which is the 100 volt. Here the primary current flowing, which is the near about 0.6 ampere. The secondary current of a transformer, which is the 1.8 ampere, and the secondary voltage of a transformer, which is and the secondary voltage of a transformer which is the 48 volt. Here we adding the load for the each reading. So the bulb is glow when the voltage is varying. Then for the third reading we set the voltage at a 150 volt. Then the current flowing through the transformer at a primary side which is the 1.1 ampere, and current flowing at the secondary side which is the 2.25 ampere, and the voltage at a secondary side which is the 74 volts. Now adding the loads and set the voltage at a 200 volts. Then the primary current of a transformer which is the 1.35 ampere, and secondary current of a transformer which is the 2.7 ampere, and the secondary voltage of a transformer which is the 100 volts. Here we see the load for the practical. These are the total readings for this practical. Now here we will see the calculations for these readings. So for these calculations we have to calculate the values of voltage ratio, current ratio and turns ratio. For first reading we have to calculate the value of voltage ratio Vp upon Vs. Here the primary voltage which is the 50 volt and secondary voltage which is the 25 volt. For the current ratio, the primary current which is the 0.4 ampere and secondary current which is the 1.35 ampere. So now we will calculate the voltage and current ratio. Turns ratio, we have find the ratio of Vs upon Vp, that is 25 upon 50. From the calculations, for the first reading voltage ratio equals to 2, current ratio equals to 0.29, turns ratio equals to 0.5. Now similarly we have to calculate for the again readings. Similarly we calculated the values for that reading. The current ratio which is nearly equals to 3 and the voltage ratio which is nearly equals to 2 and the current ratio which is nearly equals to 0.5. So here we are studying the voltage ratio and current ratio of the single phase transformer.